Hey everybody, today's tutorial comes from a question that I got from one of my native scripting students. He was asking me how to build a parallax effect based on the phone's orientation. So today we're going to be building something like this. I call it floaties, but this is basically going to affect how the phone is rendering and animating these two circles, and one circle seems to float on top of another one, and it's based on the orientation of the device. That's coming up in this video. Hey everybody, welcome back to yet another NativeScript tutorial. My name is Alex, and if you're new here, consider subscribing to the channel where you get NativeScript tips, tricks, and tutorials. Just hit the subscribe button and the little notification icon next to it so you don't miss any of them. And if you want to take deep dive into NativeScript Angular or NativeScript Vue or NativeScript Core, check out nativescripting.com, where we have tracks for each one of these different UI frameworks where you can get on-demand video training. We've got free beginner courses as well as paid advanced courses. You can check out the links in the description down below with some discount codes. So today we're building floaties. I don't know actually what technically these things are called, but in iOS, one of the options you can select as your background is an animated thing like this. It's an animated background, and each one of these bubbles kind of hovers and animates back and forth and appears and disappears. And also it looks like there's a couple of layers of these bubbles all floating on top of each other. So we're gonna kick things off by creating these layers that respond to the device orientation, and we're gonna implement an algorithm that's gonna allow them to smoothly animate back and forth. All right, let's do this. Folks, if you didn't see part 1, make sure you go see that. I left a link down below. That's where we created this little demo application. We installed the Accelerometer package right here, and then we started using the accelerometer by just displaying the X and Y and Z coordinates, and we converted the accelerometer stream to Rxjs. So if that part is clear to you, then I guess you don't need to see part 1. But if you want to start from scratch, go check out part 1. We're going to take off from here. This is the code we've written so far, and I'm mirroring my device to the screen right here. This is my actual hardware device because the accelerometer doesn't work on a simulator, so I'm running this on my iPhone that's connected to my computer via a USB cable. And I can interact with my device by leaning it back and forth and seeing the accelerometer values changed. By the way, I didn't hook up the Z-axis because we're not going to need that for this demo. So let's continue. I want to actually have some kind of UI we can actually look at and see our accelerometer in action. So I'm going to create a couple labels here. Here's the first label. Let's give it a class. Let's give it a class of label 2. Why? Because why not? And we're going to do another label, label 1. And of course, these are two different classes that we're going to need styles for. So I'm going to open up app.css, and let's just delete everything out of here. I don't need anything in here, but I will actually paste in two label styles. One is going to be red and one is going to be green. These can be anything you want, folks, really. I just wanted to have things that look very different. One is red, one is green. How much more different can you get? One is bigger, the other one's smaller. And they both have an opacity of 0.2 just so that they're translucent so you can see through them. So this is what we end up with. We just have one circle and we have another circle. And they seem like they're on top of another. In fact, they're two different layers, and this is what's going to give us that parallax 3D effect that we're going for. Okay, so let's continue. Now that we have these circles in place, we somehow need to manipulate them in space, and we need to react to our accelerometer changes. We need to move them, and in order to move them, I'm going to actually bind their translate properties here. So translate X, and I'll just say TX for that one. Of course, we need to put that in quotes. And of course, we need a translate Y property so we can move it in the other direction. We're going to skip Z here because that's not going to really affect how our labels look. We want to move only in two directions because it's a two-dimensional screen. And we'll do the same thing for the other label as well. So we're going to bind to these TX and TY properties So we need these properties in our items component. Let's go up here. I'm going to create a public TX. It's going to be 0 to start with. And also let's create a public TY property, which is going to be 0 as well. So we're going to go through a couple of iterations here of how we can update these TY and TX properties. I'm going to give you some algorithms that are going to smooth out the display of these. But for now, let's just go over here to where we're subscribing to our changes in the accelerometer. And I'm just going to update these directly. So TY or TX is going to be, let's say, data.x. And this .ty is going to be data.y. Let's go ahead and save this and take a look. Now, I'm going to tell you right now that you're not going to see much of a difference here. So I'm leading my device right now, but you don't barely see any difference unless you have a really keen eye in the circles. And that's because the values are so small that we're dealing with here. So you can see that the values of each one of these X and Y coordinates are actually between 0 and 1. So we're really only moving this by 1 pixel or 1 device independent pixel. So we need to have a bigger change here. I'm going to multiply this by 100 so we can see more of a change. All right, now I'm going to tilt the device and you will see a bit of a rough animation going on there. It's not really smooth. It's kind of choppy. So there's a couple of things at play here. One is the increment of our updates. And this is in the options that we can pass into our accelerometer. So let's go up here to where we're actually using the start accelerometer updates function. This has an override where we can pass in a second parameter that's going to be the options. So let's create const opts. It's going to be accelerometer options, and we can add the sensor delay, which is the only property in there. And sensor delay has these values: game, normal, UI. I'm going to pick UI because this is the typical user interface delay that you would want to see. And I'm going to pass this in as the second parameter here. So this will simulate 60 frames per second. I'm going to head over to the device now, and you'll see that it's a little bit smoother. The updates are a little quicker, and but still it's kind of choppy. So we want to smooth this out quite a bit. We're going to use an algorithm to do that. Now, before I show you the algorithm, let me show you something else that we can do with Rxjs. So right now we're subscribing directly to the accelerometer values, but we can also pipe this data. We can use the pipe operator from Rxjs and do some processing on that stream before we subscribe to it. And one of the things we can do is sample time. Sample time is an operator. So we're going to go up here to our imports and import from Rxjs/operators. And we're going to have a bunch of different operators here. There's a ton of them. You can go through the documentation for Rxjs to see which ones there are. We're going to use sample time in this case, and I already have it there. So what we do is we pipe an observable to these different operators, and you can have as many as you want. So I'm going to show you this sample time one. Basically, this will only emit values past this point at a certain time increment. So if I say 1000, this will be every 1000 milliseconds or every 1 second. So let's save that and take a look. That means our data points will only be updated once every second. And you can see that as a result here in the labels up at the top. And also if I lean my device over, you'll see that it only updates about once every second. So definitely a very choppy animation. However, if you had the options set to for example, fastest, that means that it's going to be as fast as possible. It's going to get that data quick, and you want to use all that data some way or another. However, for your display, you want to cut that time down and only use certain frames. You can sample it down to 50 milliseconds. And then this subscription will only be triggered once every 50 milliseconds instead of at the fastest possible rate. I'm going to set this back to UI, and sample time can actually be 16. 16 will be about the same as the UI. It's about 60 frames per second. So I'll leave that there as an operator just for us to look at. But the result of this will be pretty much the same as we've seen in the beginning. Now, how do we actually smooth this data out? Well, we can use something called a running average, where we take the last X number of values we aggregate them, and then we take the average of that. So for example, the first time this subscription gets triggered, X has a certain value, and the next time X has a certain value. If we collect, let's say 5 of those in an array, and then add all of them up, and then divide that by 5, we'll get the average of the last 5 times, or the last 5 values of X. And if we apply that to TX, TX will be the average, and it'll smooth out that whole curve. This kind of algorithm is used a lot in charting and graphing applications if you want to smooth out those curves that are displayed. So how do we do that? Well, we're gonna first need to get the last 5 values into an array. So I'm gonna show you how to do this in a plain old-fashioned way first, and then I'll show you an Rxjs alternative. So let's say we have an array of X and Y values, and we have 5 in each one. I just put zeros in there to start things off. So we have X array and Y array. In our subscription here, instead of setting TX and Y directly here, we're gonna first say this dot X array, and we're gonna shift. So we're gonna get rid of the first value from that array and push the next value onto the array. So this dot X array, push, and we're gonna do data.x times 100, but also I want these to be round numbers. They don't have to be round numbers, but I'm gonna go ahead and round them up just so it's clean. I'm gonna say math.round, and we're gonna do data.x times 100 in there. Okay, so we're gonna do the same exact thing for Y. So this dot Y array, remove the first value and add another value to the end. So now these two arrays are gonna have the last 5 values of X and Y. And let's go to our TX and TY. These will be different now. These need to calculate the average from these arrays and return that average. So we're gonna convert these to getters. I'm gonna say get TX is gonna be return. I'm gonna create a get average function and pass in this dot X array. And also let's do a get Y or get TY. I'm gonna convert that to a getter as well. Let's return get average this dot Y array. Now we need this get average function. So let's go up here. I'm just gonna create this function here. This is going to basically take in an array of numbers and return the average of those. So one way to do this, and a nice way, clean way of doing this, is to just use the reduce function. So items.reduce, we can specify that items is going to be a number array. So items.reduce, and then this is going to take an accumulator and the value. I'm going to say accumulator plus value here, and we're going to initialize it to 0. If you don't know how to use the reduce function, check out the documentation, or let me know down in the comments if you want me to do a video on how to do that, how to use the reduce function. I'll go over that in detail. And now we want to go ahead and divide the total by the number of items in that array. This will give you the average. So now we have the average, okay? And that's all there's to it. Now it's going to be the last 5 values. So this is going to smooth out that animation a little bit. So when I move this, it's not going to go immediately and follow my phone instantly. It's going to have a small little delay before it does that. And the more numbers you have in here in this array, the smoother it'll be, but also it's more calculation intensive. So keep an eye out for that. 5 or 10 is a good number. All right, so now I said I'm going to show you how to do this using Rxjs. Let's do that now. I'm going to provide a couple of other values that we can bind to. Since we are using Rxjs, I'm going to create a private. Since we are going to be using Rxjs, I'm going to convert these TX and TYs into observables. So instead of getters, let's do TX. It's going to be $, because it's an observable. So we want to use that $sign to indicate it as such. So it's going to be an observable of number. And TY is also going to be an observable of number. And let's make that TY $. Now, because these are now observables and they're different variables, we need to bind them a little differently. So here I'm going to say TX $, and then we want to use the async pipe in order to do 2 things. One is, first of all, to subscribe to the value. And second, to unsubscribe when the component is destroyed. The async pipe automatically unsubscribes for us, which is nice. We're going to do the same thing here with ty, and we're going to do this for both of these. So ty here and ty here. So we've bound everything now. We've done it with async pipes, which is great. Okay, so now we need to actually provide values to these. We're not going to be using this array anymore, or this one. Let's head down to this function, and I'm going to go ahead and delete all this code here from our subscribe function. Now, instead of subscribing directly to the accelerometer, I'm going to manipulate this first. So I'm going to create a temporary observable here, which is going to use the accelerometer, and we're going to manipulate the data first by piping it through a few different things. One of them is going to be, well, sample 16. Let's do that. Not really necessary, but we already had that in there, so I'll put it back in. Now, let's just get rid of this down here because we don't need that anymore. We're subscribing directly in our markup, so we don't need to subscribe here. How do we get our values smoothed out? Well, first of all, we need to accumulate them into an array, and we use the scan operator for that. So Rxjs comes with an operator called scan, which is going to accumulate the running values. So that's exactly what it's for. So we're going to pass this or pipe it to the scan operator, which is going to take the accumulation array of type accelerometer data array, and then the current value. And we'll initialize this with an empty array. Now inside here in the callback, we're going to need to do ac.push. So we're going to push the new value onto that array, the accumulation array. And then we're going to return. We only want to take the last 5 values, and we want to just discard all the other values from this array. So we're going to say -5. Now it's a matter of simply changing this number right here, -5, to whatever number of items you want to store in that array, so you can see how smooth it becomes if you have more than 5 in here. We'll take a look at that a little bit later. Okay, so that's the scan option, which will return to us an array of accelerometer data. So we're not directly converting this to X and Y coordinates yet. We'll do this later. We can map this over now. Map, by the way, is another Rxjs operator. So we can now map it, and map takes in a parameter that's the callback. We're going to get the items, which is now the array of accelerometer data. So if I hover my mouse over that, you can see that. Here we want to do the average now, but we can't do an average on accelerometer data. So here at this point, we're going to split this up to X and Y. So I'm going to do total X here, and we're going to take the items and then pump it through our reduce function. That's going to have the ACC, or our accumulator, C, which is the current value. Same thing that we did earlier. ACC plus math.round, and then C.x times 100 here. And then we'll pass in the initial value as 0. All right, so that'll give us the total for all the X values in the items array. All right, now we're going to do the same thing for Y values. So total Y, and then we're going to count up C.Y. Remember, C is accelerometer data. And then finally, we're going to just return an object here that's going to have the X average. So total X divided by items.length. And then the Y average, which is going to be total Y divided by items.length. So the result of this map function is an array of these. So the result of this map function is going to be this object right here. It's going to contain the average for X and the average for Y. All right, that's something that we did need up here as well. Now, how do we actually pull out the X and Y values out of here? Well, let's go ahead and do that. We have this .tx. This is the observable that we're actually binding to here in our template. We can say temp $. Temp $, is this observable we've set up temporarily to do the processing. Temp $.pipe, we can further process it even more. So this temp has X average and Y average. We only want the X average here. How do we do that with Rxjs? Well, it comes with a special operator again called pluck. The pluck operator is going to allow us to only take the X average property from here. So we're going to pipe this to the pluck property, and we want the XAVG as our result here. Okay, I'm going to save this. It probably reformats it. Yep, sure did. And I'm going to copy that to TY and say we want Y average. Now, since we're going to be processing this using Rxjs, it's going to be a little bit different. I'm actually going to not run this get average here. I'm going to run it later. So I'm going to convert these into just regular properties. I'll set them to 0 initially. Remove this get, and I'll copy this, paste it here, and this is going to be TY. Okay. Now we're going to go down here and actually subscribe to this. Now there's lots of different ways of doing this, but I just have this temp here that I'm going to subscribe to, and this is going to get me some values. I'm going to say V for that. Remember, values is actually going to be of type. It's going to have X average and Y average on there. So we're just going to say this dot TX equals V dot X average, and this dot TY equals V dot Y average. So effectively, this is going to give us the same result right here. When I move this around, you'll see that we have the animation and it's smoothed out by our algorithm here. So that's kind of nice. Now, what if I wanted to smooth it out even more? Let's say I wanted to go, instead of the 5 values in the array, I wanted to store 50. Remember, this is going to be a lot smoother, but we're also going to have a lot more numbers to crunch through here. So you have to weigh that balance. So let's take a look at this one. This is what it looks like now. I'm really lifting this thing to the side immediately, and I'm setting it down flat, and it just takes maybe 5 seconds to get to that spot. It's a lot smoother, and it takes a lot longer to animate from place to place, which really resembles the iOS background that's animated. It's really slow moving animation. How else can we imitate that background? Well, we can separate out these layers and have them move in different rates to give it that parallax effect. That's pretty simple to do. We're just going to go into the template here. You can create separate variables for this in your component, but you don't have to. I'm just going to go here right to my labels, and I'm going to say multiply this by 1.8 and multiply this one by 1.8 as well. So we're just going to translate these two labels at different rates based on the current translation base that we've calculated. And if I do that, you'll see that we have the green circle that's animating at a different rate than the red circle. And that's basically our parallax effect right there. You can apply these same translations to some kind of a layout, and your layout can contain multiple labels or multiple other UI components if you want to translate them like this. So for example, if we have a stack layout here, and I can put this label inside the stack layout like so, and this translate will go as properties of the stack layout, not of the label. And maybe I even have a button here, tap, and maybe even another label on that stack layout as well. So let's see what that looks like. And there we go. Now we have a stack layout with some UI inside of it. That's the entire stack layout is being animated, and then a floating label that sits somewhere at a different level, presumably in the parallax hierarchy. So there we go. That's how we create this parallax effect. So that'll get you started with implementing your own parallax type of screen based on the accelerometer. Now, of course, the ones that come on the device are a little bit more detailed, and they have bubbles popping in and out of view, but I'll leave that as an exercise to you to do, because compared to what we've just done, that's a pretty simple task to do. Nonetheless, if you are curious to see that, let me know down in the comments below, and I'll do the full-blown tutorial. We'll make that part 2. All right, folks, if you're not subscribed yet to the channel, please go ahead and subscribe. And you can follow me on Twitter. I'm @DigitAlex over there. And I'll catch you in the next one. Happy native scripting.